Hello, and I'm very happy to see you again. The Hadal Zone is the deepest region of the ocean, pitch dark and freezing cold. It lies between 6.000 and 11.000 meters deep. Inside long, narrow V-shaped trenches, with the Mariana Trench being the deepest of them all. And despite every bit of common sense screaming otherwise, life still exists and evolves at these ridiculous depths, becoming either hauntingly creepy or absolutely enormous. The Japanese giant spider crab, the giant red jellyfish, the oarfish, also known as the doomsday fish, the giant squid, the Greenland shark, and giant isopods. All of them are examples of deep-sea gigantism, a strange trend where deep-sea animals grow significantly larger than their relatives in shallower waters. So the question is, what exactly is so tasty down there that makes deep-sea residents grow into absolute units? In reality, it seems to be the opposite. At depths beyond 400 meters, food starts becoming scarce. Once sunlight fades away, phytoplankton that live through photosynthesis and zooplankton that live by eating phytoplankton also disappear. Without them, most deep-sea creatures have to survive on leftovers, scavenging scraps that fall from the surface waters, a phenomenon known as marine snow. Marine snow is made mostly of dead plankton, poop, and rotting bits of dead bodies slowly sinking to the seafloor as tiny particles. Some animals, such as the vampire squid, depend entirely on this food delivery from above. Of course, you still have to work if you want to eat, even if in this case, eating still means eating poop. The vampire squid uses two long filaments to catch any little particles drifting past it at around 900 meters deep, then combines them with mucus secreted from its suckers to roll bits of dead matter and feces into a food ball. But picking up individual flakes of marine snow is not exactly how you build a supersized body. Many deep-sea animals do not eat marine snow directly. Instead, they eat the animals that eat marine snow. And so, big fish eat small fish. In the deep ocean, any creature that is not the biggest thing around basically has a target painted on its back. So the secret to survival is becoming a predator. And not just any predator, but an apex predator. Please welcome the giant squid. Humans have known for a very, very long time that some exceptionally large species of squid lives in the deep sea. But until the early 21st century, everything we knew about the giant squid came from dead bodies washed up on shore. It was not until 2004 that people captured the first images of a living individual somewhere around 1.000 meters underwater. So far, the largest giant squid ever found measured about 13 meters long, roughly the size of a bus, and weighed around 275 kilograms. Not huge compared to a blue whale, sure, but definitely monstrous compared to the squid your parents usually stir-fry for dinner. Thanks to its overwhelming size, the giant squid has very few enemies, with two extremely long tentacles that look oddly fragile. It is not hard to imagine how these big boss squids grab deep-sea fish and smaller squid. But the giant squid is still not the largest squid in the ocean. That title belongs to something even more giant, the colossal squid. The colossal squid is actually a little shorter than the giant squid, but it is twice, even 3 times heavier, averaging 500 to 700 kilograms, about the size of a cow, and definitely enough protein to feed an entire wedding reception. It is not hard to imagine a creature that inspired the legendary kraken as a fierce predator ruling the deep sea, shooting through black water, devouring enemies, and tearing passing sailing ships apart. But reality, and honestly just basic logic, seems to suggest the opposite. The giant squid and the colossal squid are not active hunters, simply because they do not need to be. Kleiber's law states that an organism's metabolic rate does not increase in a straight line with its body size. To make that easier to understand, a person who weighs 100 kilograms does not burn twice as much energy as someone who weighs 50 kilograms. Or, if a cow weighs 100 times more than a mouse, that does not mean it needs 100 times more energy to stay alive. In reality, an organism's metabolic rate equals its body mass raised to the power of 3/4. This formula means that, over the same amount of time, a cat with 100 times the body mass of a mouse will only consume around 100 to the power of 3/4, which is about 32 times as much energy as the mouse. The point of this law is that the larger an animal becomes, the more efficiently it uses energy. And in this context, the colossal squid is an extremely efficient creature. According to estimates, its metabolic rate is so low that it burns only, and you heard that right, 45 calories per day, and only needs 0.03 kilograms of food per day. For comparison, yes, you, specifically you, burn around 1.300 to 2.000 calories per day, and that includes the days when you just sit around doing absolutely nothing. One adult toothfish weighing around a dozen kilograms is enough food for a half-ton colossal squid to survive for about 200 days. That is more than half a year. In case math is not your favorite animal, this suggests that the colossal squid lives life at an especially slow pace. It does not chase prey in epic battle scenes the way our imagination wants it to. Instead, it waits for prey to accidentally swim close enough. Then it uses the hooks on its tentacles to trap them. Logically, this slow lifestyle makes much more sense than a crazed sea monster sprinting after prey thousands of meters underwater. Because after all, visibility at 1.000 meters deep is extremely limited, and small prey may not even provide enough energy to make up for the calories spent chasing it. The colossal squid does indeed have the largest eyes in the animal kingdom, nearly 30 centimeters wide, almost 3 times larger than the eye of a blue whale. But scientists believe these eyes are not mainly for catching prey. They are for detecting and avoiding its rare predators. Predators such as sperm whales. So the forces driving the giant squid and colossal squid to grow huge and maintain extremely slow metabolisms come from food scarcity and the pressure of being eaten. Beyond that, cold temperatures may also be one reason some deep-sea creatures become unusually large. Bergman's rule states that within the same group of animals, species living in colder environments are usually larger than those living in warmer environments. For marine creatures, this hypothesis suggests that cold water carries more dissolved oxygen, allowing organisms to grow larger. But can this explain the unusual size of the Greenland shark? The Greenland shark is the largest fish in the Arctic Ocean and one of the largest living sharks. It can reach 7 meters long, longer than the largest great white shark, and weigh up to 1.400 kilograms. It lives at depths of more than 2.000 meters, in water temperatures from -2 to 7 degrees Celsius, and it is the only shark species that can tolerate the freezing waters of the Arctic year-round. Not only is it huge, the Greenland shark is ancient. The Greenland shark is the longest living vertebrate in the world. Its average lifespan reaches 272 years, and at most, it may live for more than half a millennium. In other words, you could absolutely find a Greenland shark that was born during Vietnam's later Le dynasty, from 1428 to 1789, and it could still be alive today. In fact, if a Greenland shark had been born when Emperor US came to the throne, that is nearly 150 years later. Wild. Like the colossal squid, the Greenland shark's incredible longevity may also come from its extremely slow metabolism. And also like the colossal squid, it is an extremely slow, opportunistic feeder. It eats fish, squid, and scavenges whatever dead bodies it can find. Believe it or not, scientists have found traces of polar bears, horses, and even reindeer inside Greenland shark stomachs. Unlike the supergiant squid, the Greenland shark could not be aggressive even if it wanted to, because it is completely blind. Do not get me wrong, these guys do have eyes, but their eyeballs are often clamped onto by some nightmare-fuel species of crustacean, leaving them almost completely blind for most of their lives. Now imagine a creature drifting slowly through pitch black, -2-degree water for more than 500 years, with horrible crustaceans latched onto its eyeballs, occasionally twitching their little legs. These things must have committed war crimes in a past life, because in this life, they got sentenced to an extremely long and extremely flavorless existence. But that is still only down to a maximum depth of around 4.000 meters. Inside Hadal trenches, between 6.000 and 11.000 meters underwater, temperatures range from 1 to 4 degrees Celsius. There is absolutely no light, and the pressure is 1.100 times greater than at the surface. Down here, even marine snow, dead scraps, and poop are not exactly abundant enough to casually collect. And yet, This is where we find the most extreme case of deep-sea gigantism. In a place where life seems almost impossible to an ordinary person, giant amphipod crustaceans crawl all over the seafloor. They are called giant because shallow water amphipods are usually only 5 to 20 millimeters long. But at these extreme depths, they can grow up to 34 centimeters long. This is Alicella gigantea, the largest amphipod ever recorded. Similarly, the tiny isopods you might find in your garden, small enough to fit on a fingertip, have ocean floor relatives that puff up like dinner rolls. With lengths of up to 50 centimeters, you may need both hands to hold one. If ordinary isopods at around 6 millimeters were the size of a mouse, then their giant deep-sea cousins would be the size of an elephant. And not just any elephant, but a fully grown African bush elephant. With a menu made of rotting bodies and scraps, scientists think their large bodies act like storage units, allowing them to store as much food and energy as possible. Whenever they get the chance, they gorge themselves until they are so round and fat that their legs barely touch the ground and they can hardly move. In exchange, one full meal can help them survive for more than 5 years. But is scavenging like that really enough? Scientists have another hypothesis. They discovered that a deep-sea amphipod species called Hirondelia gigas appears to have a special enzyme capable of breaking down plant matter. At first, that sounds ridiculous, because what kind of plant is going to grow in the silent darkness of ocean trenches? And these animals would not need this enzyme to digest dead phytoplankton in marine snow anyway. However, when scientists tested this enzyme, it directly converted sawdust and wood powder into glucose. Even more ridiculous, this enzyme works better under pressure, meaning the deeper it goes, the faster it converts cellulose into sugar. That means Hirondelia gigas may have prepared itself for the 1 in a million disaster scenario where a piece of wood accidentally sinks all the way to the deepest part of the ocean. And when that happens, they get a nice little menu upgrade. Turns out, living creatures have many ways to survive and to become huge. Which animal impressed you the most? Let me know in the comments below. And as always, remember to hit the like button to support us, subscribe to the channel, and ring the bell to watch more animal content. For now, goodbye, and see you next time.